In this lesson, we're going to do a quick review of parabolas and their properties. First thing we want to be able to know is whether the parabola is opened up or down or left or right. Now, what you need to make sure you do is always isolate the variable that's not being squared. So in this particular problem, the y is not being squared, so I would look like these blue equations up here. If the y was squared and the x wasn't, then it'd look like the red ones. Now, if the x is being squared, x squared, then it's going to either be opened up or down, and it all depends on this leading number here. So for this particular problem, all I do is go y equals negative 10x squared, because I have to bring that x squared to the right side, minus 4. And since that number in front of the x squared term is a negative, it is opened down. Now, if it had been a y squared, it would have been opened left. Now in this problem, it asks us to find the vertex. Now again, what you need to do is get it into what's called vertex or transformational form, which this one's not too difficult. You minus the 6x over, and you're basically there. Just realize that we're not adding or subtracting anything from the x before we do the squared. So our h value, or x value of our vertex, is 0, and then we shift it up 5, so our vertical shift, or our y value of our vertex, is 5 at 0, 5. This problem also asks us to find the vertex, but this one is going to be opened to the right because it's the y that's being squared. Now the first thing we need to do is get it into vertex or transformational form. So the thing I've done is in order to complete the square, to get it into vertex form, you can't have this 4 in front of the y squared. So I divided the 4 over to the right side. I divided that by 4, divided that by 4, and divided that by 4. So actually I need to put that over 4. And now what I'm going to do is half of 32 divided by 4 is not 16. It's actually 8. So 32 divided by 4 is 8, 61 divided by 4. Now I'm going to take half of the 8 value and square it, which means half of 8 is 4, 4 squared is 16. So now I need to add 16, which is going to give me this perfect square down here. But if I add 16, I got to also minus 16, which I'm going to combine with that 61 divided by 4 up there. So I'm going to minus 16. Here, though, this becomes a 4, because remember, that's what goes inside the parentheses, is half of this 8. Now I'm going to add those two fractions and get a common denominator. When I add these two fractions with the common denominator of 4, which is positive 61 minus 64 over 4, I get negative 3/4. Then the last thing I need to do is multiply both sides of the equation by a 4 to get the x by itself again. So when I do that, it's going to put a 4 here. And I also got to multiply this by 4, which cancels that 4 there, leaving it as a minus 3. Now I can see my vertex. Just remember, though, that inside the parentheses is the y value of our vertex. On the outside is the x. So our vertex is going to be negative 3, positive 4. In this problem, it asks us to find the axis of symmetry, which the axis of symmetry, all it depends on is where the vertex is. So I brought the negative 3x squared to the right side, put it in vertex form, realizing I'm not adding or subtracting from the x before I square it. So that means the x value is 0, the y value is 2. So my vertex is 0, 2, but this parabola is opened up because it's positive, which means the axis of symmetry is going to be a line that goes vertically through this vertex, which is at x value of 0. So my axis of symmetry is x equals 0. In this problem, we're also asked to find the axis of symmetry, but we need to complete the square, which is what I've done here. I've added and subtracted 16 in between these two terms to get this perfect square here of these three terms. These three terms is this y minus 4 squared. But I added 16, so I minus it. That gives me negative 24. Then I got to divide that negative 4 over, which gives me an a value of negative 1/4. This negative 24 divided by negative 4 gives me a positive 6, which now I have it in vertex form. It tells me my vertex is 6, 4. Now the y was being squared, and it's negative. It's open to the left like this. And my axis of symmetry is going to be a horizontal line through this point. So my axis of symmetry will be a y equals 4, just like here, y equals 4. Now in this problem, we're asked to find the directrix, and it's been a while since we've talked about the directrix of a parabola or its focal point. The directrix and the focal point are found by this focal length that's above and below the vertex. So the first thing I have to do is take the equation that I'm given, put it in vertex form, find the vertex, which is 0, negative 5. I'm not sure why that negative went down there, negative 5. So the vertex is 0, negative 5. I find my focal length by taking 1 and dividing it by 4 times the value in front of the squared term, which is 8, which is 1 over 32. That's my focal length. So I need to add or subtract that. But this parabola, since the x squared is positive, is opened up. The directrix is a horizontal line below it by 1/32 below this point. So I have to minus 1/32 from the y value, which is negative 5, minus the 1/32, get a common denominator, and I get a negative 161 over 32. And so my directrix is the equation y equals negative 161 over 32. In this problem, we're asked to find the focus, or that focal point. Now the first thing again is I isolated the x because that's not squared. So I have a negative y squared plus 5. That tells me that the parabola is open to the left. Its vertex is a value of x value of 5, y value of 0. So its vertex is 5, 0. The focal point will be inside the parabola, or to the left of the focus, or left of the vertex, by the focal length of 1 over 4 times the a value. Well, the a value is 1. Remember, we do the absolute value of a, so we don't worry about the negative 1, just that it's 1. So the focal length is 1/4. We minus 1/4 because we're going to the left of the vertex from 5. So I minus 1/4 from 5, and I get 4 3/4. Now IXL likes improper fractions. 4 times 4 is 16. 16 plus 3 is 19 over 4. So 19 over 4 is the 4 3/4, comma 0. In this problem, we'll do this last one. We're asked to find the directrix, which we need the focal length. We need to know what the vertex is, whether it's open right or left, up or down, and if the directrix is to the right or to the left. So this one, first of all, the y is being squared, the y squared. Here I completed the square, added 4 minus 4 to get these three terms to be a y minus 2 squared, which minus 4 minus 16 gives me a negative 20. Divide both sides by negative 5, which gives me negative 1/5, parentheses y minus 2 squared, plus 4, because the negative 20 divided by negative 5 is positive 4. Tells me my vertex, since it's the y that's squared, this is my x value, is 4 for my vertex and a y value of 2. So my vertex is the point 4, 2. I also know that it's open left because it's a negative a value, which means my directrix is to the right of my vertex, and I need to be to the right of it by the focal length. Now the focal length is 1 divided by 4 times the a value. Well, the a value is 1/5, so 4 times 1/5, so I have 1 over 4/5, which when it flips, it's 5/4. So I need to add 5/4 to this x value because I need to move to the right of the vertex. So I add 5/4 to the x value, which gives me 21/4. So my directrix is going to be the equation x equals 21/4. And when I plug that in here, it kind of messes up the one I type, because as soon as I hit this fraction, it makes everything kind of go weird. But let's make sure that I've done this correctly. Excellent. If you have questions or concerns on how to do this, please do ask me in class.